Locked in a trade fight with Donald Trump, you may have heard that the Carney government is reconsidering its multi-billion-dollar purchase of American F-35 fighter jets.
U.S. weapons manufacturer Lockheed Martin is reportedly pitching new jobs for Canada. But that offer depends on Ottawa sticking to its plan to buy Lockheed's F-35 fighter jet.
Canada reviews a deal to buy U.S.-made F-35s. The reason for that review? Trump's trade war on Canada.
The story of the SOB Gripen has always centered on pure practicality. Fighter crafted for nations that demand genuine combat power without draining enormous defense budgets. Then, the data started behaving strangely. Infrared signatures plunged into ranges typically seen only on stealth platforms, while range numbers stretched way past what any single-engine fighter ought to achieve. NATO analysts only caught on after the anomalies kept showing up, test after test. This wasn't from some flashy new weapons suite or a headline-making overhaul. The real driver came from a company famous for luxury engineering, not dogfights. Rolls-Royce quietly reworked the Gripen's core capabilities, and the impact spread faster than anyone anticipated. How did such a profound upgrade slip under the radar for so long? What exactly did NATO overlook? And just how transformative can this evolution become? For much of its career, the Gripen E was judged through a narrow prism. A smart, balanced fourth-generation machine built for affordability and versatility rather than extravagance. Smaller air forces loved its low operating costs, easy maintenance, and adaptability. But hardly anyone placed it in the same league as top-tier stealth jets. That view held firm, even as something far bolder was quietly taking form behind closed doors. Shielded from public scrutiny and political spotlight, under the unchanged skin of the aircraft, a subtle technical revolution was unfolding, one that would eventually compel NATO planners to question decades-old assumptions. At the heart of it stood Rolls-Royce, not the car side everyone knows, but their elite aerospace division that rarely makes headlines because so much of its work hides deep inside. Systems never meant to be seen, but when Swedish engineers hit the limits of the Gripen E, they pinpointed the real choke point, not the airframe, avionics, or weapons base, but the engine itself. The issue wasn't raw thrust, it was how heat, airflow, and control logic were handled at near microscopic precision. Rather than swap out the General Electric F-40 Sweden took a stealthier route. They brought in Rolls-Royce to re-engineer the internals, focusing on behavior over appearance. No press releases, no big exposés, no typical fanfare that flags major fighter upgrades. The team zeroed in on airflow channels, thermal layering, and adaptive algorithms that dictate engine reactions under shifting demands. These weren't superficial tweaks or they demanded precision at tolerances, measured in fractions of millimeters and milliseconds under extreme stress. Externally, zero change. On spec sheets, same engine family. To anyone scanning public docs or photos, nothing looked different. Most of NATO and, even much of Sweden's political leadership stayed in the dark on the details. The logic was strategic, not cloak-and-dagger drama. Any open admission would spotlight the implications, especially how it reshaped the jet's detectability and reach all without touching visible traits. That alone carried serious weight. The first clues surfaced not in announcements, but in raw data. During standard NATO exercises and evaluations, sensors picked up IR readings that defied logic. In contested radar environments, infrared remains vital heat-seeking. Missiles thrive on predictable thermal profiles. Yet, Gripen E numbers came back anomalously low. Initial reaction, equipment glitch, recalibrations, fresh sensors, cross-checks, nothing budged. Rolls-Royce had rebuilt the engine's thermal management from the core outward, heat redistributed, diffused, and controlled to concentrated exhaust plumes. The results shoved the Gripen E into thermal territory once reserved for twin-engine stealth designs. For a single-engine bird, this upended basic physics assumptions. Confusion turned to alarm as consistent tests reinforced the pattern. Reduced IR visibility seriously disrupted missile lock and tracking. The second breakthrough hit combustion efficiency. Old logic said more range meant bigger fuel tanks or extra engine siding weight, cost, and headaches. By refining internal pathways and fuel oxidizer mixing across conditions, Rolls-Royce squeezed far more energy from each drop of fuel. That range jump wasn't modest. It hit levels that normally demand heavier twin-engine platforms. For nations spanning huge territories like Canada patrolling the Arctic, this flipped the equation. Long-endurance missions could shift to lighter, cheaper Touran jets without sacrificing agility. The third pillar came via digital engine controls. Rolls-Royce layered in adaptive modeling, letting thrust adjust at blistering speeds. Throttle lag vanished. Pilots described acceleration that felt alien even to veterans. The jets surged or broke away with near-instant response, outpacing legacy interceptors. In combat sims and drills, this translated to real edges, quicker repositioning, cleaner disengagements, faster opportunity grabs. Sweden kept granular data classified, but but enough leaked through NATO channels to trigger internal reviews. Doctrines built on predictable thrust curves suddenly looked outdated. Taken together, sharply lower IR footprint, vastly extended legs, lightning throttle, response to Gripen, gained survivability traits far exceeding its original category, all without altering the external engine profile. Visual checks or paperwork showed nothing amiss. For NATO planners, this sparked a reckoning. A budget-friendly single-engine fighter had vaulted into performance realms once dominated by multi-million-dollar behemoths. Clarification, requests flew. Closed-door Brussels talks followed. Sweden admitted optimizations but dodged technical specifics, keeping language precise and guarded. The fuller picture emerged later via indirect analysis. Vibration fingerprints from joint ops matched Rolls-Royce's signature micro-engineering precision. No denying the involvement in reshaping ultra-sensitive internals. That reframed everything. The Gripen E morphed from solid upgrade to both opportunity and wildcard, proving elite. Performance no longer demands the priciest procurement tiers. For NATO, it exposed gaps in oversight. Invisible internal changes evade export tracking, satellite watches, or budget disclosures. Thanks for watching. If you enjoyed this, hit like, subscribe, and turn on notifications. Your support keeps these coming. Catch you in the next one.